So list A, we have some numbers, and list B, we have some numbers. Quantity A gives the standard deviation of the numbers in list A. Because both numbers in list A and B are on group data, the first thing we need to do is to write the formula for standard deviation. So let me scroll this down for the purpose of space. So standard deviation is the square root of what? Variance. Standard deviation is the square root of variance. Alright, so in that case, if I'm writing it, that would be what? You can say that standard deviation for an ungroup data is the square root of summation x minus mean square over what? Over n. So that implies that before we can get the standard deviation for list A, we need to know the mean of list A. And we know that mean for an ungroup data is summation of the data item over number of entries. So this will give us, so this one will be for list A. So let's say list A here. So x bar, which is the mean, will be what? 0 plus 5 plus 10 plus 15 plus what? 20. 1 2 3 4 5, everything divided by 5, and that will give us 0 plus 5 5 5 plus 10 15 15 plus 15 30 30 plus 20, that's 50. So 50 divided by 5, and 50 divided by 5 would give us what? 10. So that is the mean for list A. Alright, so let's decompose A first. There are two ways by which you can determine the standard deviation. I can determine it using tabular method, and I can determine it using, just expressing the formula directly. However, we need the variance first. So let me first engage the non-tabular method. So how many items do we have in the list A? We have 0. So we first start with what? X minus x bar. Then you square it. What is the first item? That is 0 minus what? Mean. That is 50 divided by 5, which is 10. So that's 0 minus 10, right? Square plus the purpose of this plus is that it's talking about summation. So plus what? Open bracket. Next item is 5 minus 10 square, then plus what? 10 minus 10 square plus 15 minus 10 square, then plus what? 20 minus 10 square, then everything over what? Over n, and n in this case is what? 1 2 3 4 5 over 5. Okay, now whatever we get here is actually the variance. So we're actually solving for what is inside the square root. So this will now return, so let me say this is the variance. So this will now return 0 minus 10, so that will give us minus 10 square, right? Plus 5 minus 10, that is minus 5 square, plus 10 minus 10, that is 0 square, plus 15 minus 10, that is 5 what? Square, plus 20 minus 10, that is 10 square, then everything divided by 5. So the variance will be minus 10 square will give us 100. Perhaps somebody is saying, how come? Minus 10 square is the same thing as minus 10 to bracket minus 10. Minus times minus, that is plus, and 10 times 10, that is what? 100. Okay, so yeah, that's very important. So we have what? 100 minus 5 square will give us what? 25, plus 0 square, that's 0, plus 5 square, that is 25, plus 10 square, that is what? 100. Then everything divided by what? 5. 100 plus 25, that is 125, plus 25, 150. 150 plus 100, that is 250. So this will give us 250 divided by 5, and 250 divided by 5 will give us what? 50. So the variance is 50, where standard deviation will give us square root of what? Variance, and that will give us what? Square root of what? 50. And square root of 50 will give us what? 7.0711. So this will be our what? Quantity A. So this will be what? Let's just put it as square root of what? 50 here. All right, yeah, so that's that. Now let's move on to quantity B. Quantity B, it says that the standard deviation of the numbers in list B. So let's calculate the standard deviation for this. So for B, we still need the mean. So the mean for list B will give us was summation x over n, which is what, 5 plus 10 plus 15 plus 20 plus 25, then everything divided by n. That's 1 2 3 4 5. That's number of observation. That is 5. 5 plus 10 15, 15 plus 15 30, 30 plus 20 50, and 50 plus 25, that is 75, divided by 5, and that will give us what, 15. So the mean for that data is what, 15. So the next thing is for us to get the variance. So what will be the variance? The variance is what, summation x minus what, mean square over what, over n. So let's plug it in. So we now have each of the x. Okay, each of the x has been represented here instead of me having to look at it here. So this will now give us what? So variance will now be what? 5 minus x bar, that is 15, then square, plus what, 10 minus 15 square, plus 20, no, 15 minus 15, 15 minus 15 square, plus what, 20 minus 15 square, plus what, 25 minus 15 square, then everything over n, that is 1 2 3 4 5, divided by what, 5. So let me scroll up. So we now have what, the variance will now be 5 minus 15. This is 15, don't let's make mistake. 5 minus 15 will give us what, minus 10 square, plus 10 minus 15, that is minus 5 what, square, plus 15 minus 15, that is 0 square, right, plus 20 minus 15, that is 5 square, plus 25 minus 15, and that will give us what, 10 square, then everything over 5. So if you look at it, minus 10 square will give us 100, plus minus 5 square, that's 25, plus 0, because 0 square is 0, plus 5 square, that is 25, right, plus 10 square, that is what, 100. So adding all of these together, we give over 5. So finally this will give us 100 plus 25 125 plus 25 150 plus 100, that is what, 250 divided by 5, and 250 divided by 5 will give us 50. So standard deviation is equal to square root of variance. So we can say that standard deviation in this case is also square root of what, 50. So for quantity B, right, we have what, square root of 50. So by observation, quantity A and quantity B, right, are equal. So the correct option is this what, option. And I said something while I was explaining this, that one may decide to use the tabular method in solving these two problems. So I will quickly do that now. Perhaps that could be the method that will actually work for someone. So let me use tabular method for each of them. So tabular what? Tabular method. When I say tabular method, I want to tabulate the information. So list A, these are the numbers in list A. We have 0, 5, we have 10, we have 15, we have what, 20. And in order not to waste time, we've gotten the mean. The mean, which is summation x over n, is what, is 10. And we already know that we need the variance before we get the standard deviation. So the variance is what, that's summation x into brackets x minus what, mean, then square over n, while standard deviation is what, square root of what, variance. Okay, so having this, so let's first calculate the variance. Now what are those information that will be what, on this table? And these are, we need our what, oh sorry, I made a mistake in this formula. Let me rewrite it. This is supposed to be summation x minus what, summation x minus x bar, then square. That's what I wanted to write. All right, so the information that will be on in the table will comprise of column for x. So let's create the column. we have column for x, then we can create a column for x minus x bar, then we create another column for x minus x bar square, and that's all. So those are, because it is the formula that will determine the how the table will look like. So this is our x is what, 0, 5, 10, 15, and what, 20. Then the next column will be what, x minus x bar, that's x minus main. We have x minus what, x bar. Then the next one should be what, x minus what, x bar square. All right, so that's all. So this fourth column is not necessary. Okay, so now let's proceed. What is x minus x bar? That is 0 minus 10. That will give us what, minus 5. Then x minus what, x bar, 5 minus 10. Okay, we have 0 minus 10, that is minus 10, pardon me. 5 minus 10, that's minus 5. 10 minus 10, that will be 0. 15 minus 10, that will give us 5. Then 20 minus 10, that will give us 20. So x minus x bar square means we take the square of this, right? Minus 10 square will give us 100, minus 5 square will give us 25, 0 square will give us 0, 5 square will give us 25, then 10 square will give us what, 100. Okay, so now summation x minus what, x bar square is the addition of everything here. So this is 100 plus 25, that's 125. Then plus 0, that's 125, plus 25 again, 150, plus 100, that will give us what, 250. And don't forget that n in this case is 5. How do I know? The number of observation, that's 1, 2, 3, 4, 5 is 5. So we can therefore say that what, variance will give us what, 250 over what, over 5. And 250 divided by 5 will give us what, 50. And standard deviation in that case will now be what, square root of what, variance, and that will give us what, square root of what, 50. So that is why our quantity A here gives us root 50, which we decided not to decompose. Then let's move on to quantity B. So let me list the data item for quantity B. So I can put quantity B here. So for quantity B, we have what, list what, B. So for list B, we have what, 5, we have 10, we have 15, we have 20, and we have 25. And we have gotten the mean from the previous explanation, which doesn't change, to be what, to be 15. So let's create our table. So the first column on the table will be the value of x, right? Then the second column will be what, x minus what, mean, right? Then the third column, because that's the formula that determines, as x minus mean, then square. All right, so these are the content of the what, column. So what are the value of x? X here is what, 5, we have 10, we have 15, we have 20, then we have 25. So x minus mean, that's 5 minus 15, that is minus 10. 10 minus 15, that is minus 5. 15 minus 15, that is 0. 20 minus 15, that is 5. 25 minus 15, that is 10. X minus mean square, that's minus 10 square, that is 100. Minus 5 square, that's 25. 0 square is 0. 5 square is 25. 10 square is what, 100. All right, so if you take the sum of this will give us what, summation x minus what, x bar square, and that will give us 100 plus 25, 125, plus 25, 150, plus 100. That will give us what, 250. All right, so having gotten that, then we can therefore say that the variance will now be equal to what, 250 divided by 5. That's just, making use of the initial formula that I put here, this variance. Okay, summation x minus x bar square over n. So if we plug it into this, so the variance 250 divided by 5, and 250 divided by 5 would give us what, 50. So standard deviation, which is the same thing as square root of what, variance, that's square root of variance, will be what, square root of what, 50. So from what we have here, our standard deviation is what? Square root of 50. So that makes the quantity A and quantity B to be equal. So the two quantities are equal. Thank you for watching and see you in the next video. Bye bye.